Dear students, this video is about basics of semiconductor lasers from electrons to photons. In this video, we are going to discuss about the basics of semiconductor laser, understanding the fundamental ideas of the semiconductor laser, the types of semiconductor laser and differences between the homo junction, hetero junction, and describing the operation of semiconductor lasers, diagrams like band gap and the characteristic curves. Finally, applications and drawbacks. So what is a laser? Laser is an acronym of light amplification by stimulated emission of radiation. How a light can be amplified? Light can be amplified in terms of intensity. What are the characteristics of laser? Laser have four important characteristics or key features, which is highly monochromatic. It is a single color with a single wavelength. Highly directional. It is highly directional, which is not deviated or diffracted. Less diffraction occurs in laser. Since it is highly directional, it is a highly intense beam, bright beam, and finally coherent beam where all the waves are in phase. So, what are the basic principles of laser action to take place? There are 3 points you have to remember under basic principle of laser action: absorption, spontaneous emission, and stimulated emission. Absorption. While discussing about all these 3 processes, you should remember the energy levels in an atom. We all know there are a number of energy levels in an atom: minimum energy level or ground energy level and the higher energy levels. In the case of absorption, you can see, let us imagine an electron is present in the lower energy level E1. A photon of energy h nu is made to incident on the electron present in the lower energy level. Electron will absorb energy from the photon and it get raised to the higher energy level E2. This process is called absorption. Second is spontaneous emission. The electron which get raised to the higher energy level from the lower energy level will come back to the lower energy level with the emission of photon of energy h nu. Since it is occurring spontaneously, it is called as spontaneous emission. Third one is stimulated emission. Some of the electrons which are in higher energy level, they need a photon to incident on it to get energy and to come to the lower energy level E1. Since it is stimulated externally, it is called as stimulated emission. These electrons will come down to the lower energy level with the emission of 2 photons. Population inversion and optical feedback. Population inversion, you can say, this is the condition required for a laser action to take place. Population inversion is the number of electrons in the higher energy level should be greater than the number of electrons in the lower energy level. N2 should be greater than N1. This is the non-equilibrium condition essential for laser action. Optical feedback and resonator. There are 3 main components of laser action to take place: active medium, active material, and also the optical resonator or optical feedback. Optical resonator, it is nothing but it consists of 2 mirrors. One is partially reflecting mirror and the second is 100% reflecting mirror, fully reflecting surface. I can say that the active medium is placed between the partially reflecting mirror and the fully polished mirror. Now, due to the stimulated emission, the electrons will get bombarded between the 2 reflecting mirrors, and this occurs for many times, and at a threshold point, the highly intense laser beam is emitted from the partially reflecting mirror. So these are the important points you have to remember while talking about the laser. Types of semiconductor laser. There are 2 types of semiconductor laser. One is homo junction semiconductor and second is hetero junction semiconductor. Homo junction, it clearly gives an idea that both p-type and n-type material are same. P region and N region are made up of same type of semiconductor material. The diagram gives you an idea about P region is made up of gallium arsenide, N region is made up of gallium arsenide, and there is a junction between the P region and N region, and that junction behaves as a I can say that is the junction behaves as an active medium, and the two sides of the junction behaves as a optical resonator, and the process occurs with the bombardment of electrons between the two reflecting surfaces, and as a result, at the threshold point, highly intense laser beam is emitted. We can see the two metal contacts at the upper side and the lower end, which is connected to the circuit. And heterojunction semiconductor laser. Here there are two types: single heterojunction semiconductor laser and double layer heterojunction semiconductor laser. Here this is important that you have to remember that P region and N region are made up of two different semiconductor material. So in single semiconductor heterojunction laser, you can say that N region is made up of gallium aluminum arsenide, P region is made up of gallium arsenide, again with the P region of gallium aluminum arsenide. In the double heterojunction semiconductor laser, we have 5 layers: P layers on the top and N layers on the bottom, or vice versa, with a combination of gallium arsenide and gallium aluminum arsenide. And the third and fourth layers junction will behave as a optical medium for the laser action to take place, and we get the highly intense laser beam from the partially reflecting mirror. Homojunction semiconductor laser. Definition for homojunction: it is a semiconductor laser in which P region and N region are made up of same semiconductor material. PN junction region acts as the active medium. P region and N region are made up of gallium arsenide. Principle of homojunction semiconductor laser. It operates under the forward bias condition. What do you mean by forward bias? P region is connected to the positive terminal and N region is connected to the negative terminal. As a result, electrons from N side and holes from P side are injected into the junction region. Radioactive recombination. The carriers, both electrons and holes, will recombine in the junction and they emit photons. Population inversion. This is at high injection current. Population inversion is created in the junction region. As a result, stimulated emission occurs, and by continuing the stimulated emission at some threshold point, highly intense laser beam is emitted. Construction of the homojunction semiconductor laser, it is clear from the diagram. P region is made up of gallium arsenide, N region is made up of gallium arsenide, and we have two metal contacts at the bottom and the top, which is connected to the to the external source with a positive and negative. P region connected to the positive terminal, N region connected to the negative terminal, which provides forward bias for the PN junction diode to operate. Working of homojunction semiconductor laser, it is a recap of that. It is a forward bias is applied, recombination occurs, population inversion take place, stimulated emission and feedback of the electrons will occur, and finally laser output is obtained. Characteristics and applications. Key characteristics of a homojunction semiconductor laser is: laser exhibits specific performance characteristics related to threshold current, output power and operating conditions. Applications, we know laser finds its application in day-to-day life, for the physics laboratories, for even in educational demonstration kits, and it is important to develop compact lasers. And energy level diagram: valence band, conduction band, where electrons are present in conduction band, holes are present in valence band, recombination of holes and electrons occurs, and laser beam is emitted. Drawbacks and limitations of homojunction laser. There are 6 points you have to remember here. The first is very high threshold current. Requires extremely high current density to achieve laser action, which is practically impossible during all the environment conditions. And poor confinement. Inadequate confinement of both charge carriers, electrons and holes, and optical field. Thermal problems. It generates heat high heat during operation, thermal management issues, low efficiency, poor conversion of electrical energy to optical output, limited operation, not suitable for continuous wave operation at room temperature, and obsolescence, mostly replaced by heterojunction and double heterojunction structure lasers. Thank you for watching this, and let us all meet in the another video. Thank you.